Hello everyone, in this video I'm going to be showing you how to graph an exponential function using transformations. So let's just jump right into it. So the first step you want to take when graphing any function using transformations is to identify the base function. So what you do is you just look at whatever the base is and then just write it to the x power. So I'm going to call it g of x. So our base is 3 and it's to the x power. And that's it. That's your base function or parent function, starting function. So I'm going to refer to it as a starting function. So then you need to identify, the next steps is to identify some key points. So I'm going to choose -1, 0, 1, x, and then evaluate the function at those points. So g of -1 is a third, g of 0 is 1, and g of 1 is 3. So then we also have to note our asymptote. So an exponential function has a horizontal asymptote y equals 0. And this is what the book starts with, are these points here. So then I'm going to rewrite the function that I'm going to need to graph. And I'll write a chart for it as well, because it'll need some points. Okay, and then right here, the next step, important step, is to write the arithmetic that will do our transformations for us. Okay, so this is the important part right here. So let's look at what happened from this x value to here. So it looks like we subtract 1, but we actually add 1. We actually do the opposite operation. So we shifted, it shifted right 1 unit. There was a horizontal shift. And I'll show you that, why the reason is why you do the opposite operation to your x values, why that is in a minute. And then to the y values, so g of x is function notation for y. So from this y, so this is y, to here, we multiplied it by -2 and added 4. So we're going to multiply by -2 and add 4. So to the y, the arithmetic, you just, however you see it is how you write it. So, and we'll talk more about that transformation here in a minute. So let's go and do our arithmetic that's going to do our transformations for us. So to all the x values, I'm going to add 1. So to all these x values here, I add 1. And then to all the y values, I'm going to multiply them by -2 and then add 4. So that's what I'm going to do to these y values, including our horizontal asymptote, because that's also y value. So I'm going to add 1 to all these x's. So -1 plus 1 is 0, 0 plus 1 is 1, 1 plus 1 is 2. And then I'm going to take all these numbers here and multiply by -2, add 4. So 1/3 times -2 is -2/3 plus 4. So let's look at the approximate value. So we have -2 divided by 3 equals plus 4. So it's about 3.3. 3.3 repeating. And then 1 times -2 is -2, plus 4 is 2. 3 times -2 is -6, plus 4 is -2. Okay. And also this y value, this is a y value as well. So our new vertical, so our new horizontal is going to be at 0 times -2, which is 0, plus 4 is 4. All right, so let's look at our starting function really quickly. So let's put this down on the graph. So we have y equals 0. I like to do my asymptote. We have -1 and then a third. So -1, a third. So more like here, 0, 1, and then 1, 2, 3. And then this is the shape of it. Just connect the dots and kind of just approach the graph will approach the asymptote. So it'll keep getting closer and closer to it, but it will never cross or touch. And then now let's do this one. So what we're going to do is take this graph, and you'll see here in a minute once we plot these points. Take this graph, shift it, do a horizontal shift right one. We're going to do a reflection about the x-axis, right? Because the y has become negative. So it's going to flip. We're going to shift it up 4, and it's going to stretch by a factor of 2. So let's just see that. So we have, I like to do my asymptotes first, place those down first. So we have y equals 4. 1, 2, 3, 4. So a dotted line, an asymptote is denoted by a dotted line at y equals 4. And then we have 0, 3.3. So 0, 1, 2, 3. So like right here. And then 1, 2. So we have 1 and then 2 there. And then 2, negative 2. So 2, negative 2. So here. And then we're just going to connect the dots and just approach the graph. The graph again approaches the asymptote, so it's supposed to be getting closer and closer to it, but never cross or touch. And that's it. This is the answer. This is the graph of this function using transformations. So what we did is we took it and it shifted right one, went this way, and it got flipped. You can see that flipped about the x, and went up 4. And see how clearly you can see from the horizontal, it's up 4 units now from 0 to 4, and it had a vertical stretch. So the graph came closer to the y-axis. And that's it. That's all you do. That's the how you graph an exponential function using transformations. So real quick, let's find the domain and range of this graph here. So the domain of the function. So the domain of any exponential function is negative infinity to infinity. And the range, you start low, you read the graph from the lowest to the highest. So it keeps going down forever. So it's negative infinity. And then you follow it up to 4. But we don't include 4, of course, because that's an asymptote. And that's it. That is how you do it. So again, to just summarize really quickly here, this first step you want to take when graphing a function using transformations is to identify the starting function. Step 2, some key points. And I just choose negative 1, 0, and 1 because those are small, easy numbers to evaluate function at. An exponential function always starts with the horizontal asymptote y equals 0. And then I just rewrite the function and I put a little chart here. And then here, the next step is the important part. That's where you're writing the arithmetic that's going to do the transformation for you, this right here. So how do you do that? You look from here to here. X is the opposite. We do the opposite operation. And then the y is just however you see it as is. We change into the y values. However the arithmetic is, you just write it down. Do this arithmetic on these points. Get your new points. Put them down on the graph. And you're done. There's your transformation. So why is it that with the x, you do the opposite operations, the opposite yeah, arithmetic. So when we evaluated this function at these x values, it's really easy. We choose these, evaluating 3 to the negative 1, that was easy. 3 to the 0, 3 to the first. It was easy. No, it was an easy thing to do. We want that to be the case here as well. So if I want to evaluate, if I want this to be 3 to the negative 1, so this needs to be negative 1. This right here. So just as side work, I'll do that over here. Let's see. I can do it up here. Just as an aside, we want this to be negative 1. And so the reason why it's opposite is because we're solving for x. So we have to add 1. So then we get x equals 0. Right? There's our 0. So if I put that 0 in here, that gets me my 3 to the negative 1. Right? If I want this to be 0, right? I evaluated this function at 0. It was really easy. It was a nice number. So if I want to do that again, if I want this to be 0, well, again, I have to add 1 to solve for x, right? And I got 1. So 1 in here is 1 minus 1, which is 0. And that's what I wanted. If I wanted it to be a 1, well, x minus 1 would have to equal to 1. And I would have to add 1, right? I have to add 1. So add 1, so I get 2. And I plug that in here. Well, 2 minus 1 is 1. It got me the 1 I wanted. And then as far as the arithmetic for the y value, it's as is, because then you just follow the order of operations, right? If we were to plug this in here, plug a 2 in here, 2 minus 1 is 1, 3 of the first is 3. Then we multiply it by negative 2, and then we add 4. We're just, once you plug it in, plug that x value in, then the y values, you're just following the order of operations, right? Anyways, that's the reasoning behind it. We don't need to do any of this. We just look at what's being done. X is our opposite. Y's are the same. All right, guys, that is all I have for now. I hope that helped, and I will talk to you on the next video. Thanks, guys. Bye.